All right, everybody, so here we are. We're about to take on the magnesium oxide lab. There's a couple different variations on this. We are going to use it to kick off our nomenclature unit, and we are going to show you basically through this lab, and if you're doing the lab, you'll experience it, how we derive some of the first chemical formulas experimentally. And then the rest of the stuff that we do in this unit will kind of be like making use of all those hundreds of years of chemistry research so you don't have to experimentally determine every single formula you're going to use. So here we have our lab set up. We have our Bunsen burner over here. We have our ring stand with our iron ring, and then sitting on top of the iron ring is a pipe stem triangle. And then inside the pipe stem triangle is a crucible. Most crucibles are made out of porcelain. This crucible happens to be made out of stainless steel. It's a lot more durable, and it's actually going to allow this lab to happen a lot more efficiently. You can tell I'm handling it with my hands, but the lab that we're about to take on is a very precision-oriented lab, and we want to make sure that this crucible is clean of any impurities before we begin. So the first step to this lab is going to be to burn off these impurities for about 5 minutes. So I'm going to fire up the Bunsen burner here, and we are going to heat it up pretty much as hot as we can for 5 minutes straight. And then after that point, I am no longer going to handle this crucible with my hands at all, because I don't want to transfer any dirt or oil from my hands to this crucible and somehow affect the mass of the experiment. So here we go. I've got my Bunsen burner. I've got the gas turned off down to the Bunsen burner base. It's also turned off here at the gas valve. I'm going to turn the gas valve on. Got my lighter, wrist to the ceiling. I'm going to light my lighter and bring it down next to the Bunsen and slowly open the gas from the bottom. Shows the light because I can hear the gas. There we go. This is a terrible flame. If I put that under there right now, it would get carbon and soot all over the bottom of the crucible and definitely ruin this experiment. So we want to adjust this Bunsen burner so that it is properly and appropriately sized. So I've got that nice inner blue cone. I can hear a roar, and then I'm going to blow it out with my. Okay. So right now it's actually a little bit too close to the crucible. I'm going to adjust the flame a little bit. I'm going to bring this up so it's in the hottest part of the flame. And there we go. We're going to heat this for 5 minutes, burn off the impurities on the crucible and the lid. And while that's happening, I am going to prepare my magnesium. So here we have a ribbon of magnesium. Technically, if you're doing the full thing, you're going to use about a 15 centimeter long piece of magnesium, but I'm using the small one for show. The magnesium ribbon has a lot of oxidation on it from the get-go. So the first thing we're doing is we're going to take off all that oxidation using steel wool until it is nice and shiny. Almost shiny, almost as shiny as aluminum foil. You're not going to quite be able to see yourself in it, but we're going to get it pretty close. So we've got a nice start to the shine on the ribbon here. And just like any good cooking show, I have a sample that I've prepared earlier, because not only do we shine it, the next step is to cut it into very tiny pieces so that when the reaction is occurring, the reaction will happen most efficiently with these smaller pieces. So right now, I'm going to let this crucible continue to heat for a few more minutes. Then I will cool it off on the base of this ring stand over here with the aluminum foil, and the aluminum foil is there to prevent any dirt that was on that ring stand from attaching itself to the crucible. And we'll pick back up in a few minutes when we're about to measure the mass. All right, so here we are back again. We've burned off the impurities for a good 5 minutes, and now we've let it cool on this aluminum foil. So we're going to put it in this analytical balance right now. Again, now that the impurities are burned off, I'm going to be sure to handle this with tongs the entire time so I don't transfer any dirt or oil. So we're going to put this in the analytical balance here. Throughout the lab, we're going to measure both the crucible and the lid. Now technically this draft guard should be attached to this analytical balance, but life happens. The mass of the crucible lid is 27.508 grams. 27.508 grams. Now, the next thing in the data table is to put the metal, the magnesium, that I've previously shined and cut up into the crucible. So, handling everything with tongs, move this ring out of the way. I've got my magnesium ribbon in this weigh boat here, and I'm going to have to very carefully use a scoopula to try to get as much of it into the crucible as I possibly can. There we go. Get the lid back on here. And put it back in the analytical balance. Draft guard back in place. And the final mass is 28.026 grams. 28.026 grams. All right. So we could wait for that to oxidize on its own, but we would be waiting about 50 years for it to fully oxidize. Maybe not quite 50 years. We're going to help it along with a little bit of heat. So we're going to relight our Bunsen burner here. Actually, put the crucible back on clay triangle first. And light our Bunsen burner as before. Nice roar. Okay, we are going to put it underneath the crucible. And now the reaction will start to happen pretty quickly. The magnesium is going to react with the oxygen. The oxygen is coming from the air. Obviously the crucible is a pretty enclosed space, so in order to make sure that the reaction is getting enough oxygen, we are going to occasionally crack the lid of the crucible. But we are going to make sure that we are not looking inside the crucible at the same time, because this reaction is going to produce ultraviolet light, and it's generally not good for your eyeballs. So we're going to let this go. We're going to crack this about once every minute or so, and then we will be taking it off the heat to stir it before we put it back on. So at that point in time, we will show you the middle of the reaction and what it looks inside the crucible, looks like inside the crucible, before we put it back on the heat. Okay, we saw a little bit of smoke coming out. It's probably a very small amount of the product, magnesium oxide, that we're forming, so we don't want to just let that disappear into the air. Keep the lid on, just cracking it occasionally.
All right, guys, we got about the halfway point of turning the magnesium into magnesium oxide. It's been on the heat for about 5 minutes. Now we're letting it rest for a little bit. We're going to stir it up so it all gets evenly heated. We'll put it back on the Bunsen and continue to heat.
All right, everybody, so here we are. We have completely heated our magnesium on the Bunsen burner over here. We've let it cool off. Now I'm going to add about 4 drops of distilled water to decompose any nitrides that may have formed, maybe like 6 drops during the reaction, because not only is there oxygen in the air, there's nitrogen in the air too. And I want to make really sure that I don't smell this, because it's going to decompose as ammonia, which is going to be really terrible to smell. I smelled it anyway. All right. So here we go. I'm going to fire up the Bunsen burner again, and then put it back on the heat to drive off any water. Close, close. Slowly open the gas. There we go. That's some oxygen. And put the crucible back put the lid partially on so we don't lose any product, but also allow the water to escape. Hit it with the heat. Let this go for 2 to 3 minutes, and then we will let it cool back down and take a mass. After we take the mass the first time, we will pop it back on the heat for another 1 to 2 minutes, reheat it just to make sure all the water was completely gone and we get a consistent mass. And we will be back at you with that consistent mass when we've got it. All right, so here we are. We have added the water to decompose the nitrides. We heated once to drive off the water, then we took the mass, then we reheated it, and now we're about to take the final mass and make sure that they both agree, because we wanted to make sure that all of that water was fully driven off by the heating process. Now, I've heated it. I have burned the magnesium. Generally, when you think of burning things, you think, poof, be gone, right? Your campfire logs, they all disappear. But in this instance, before we had magnesium, then we burned it. Now we have magnesium oxide. So ponder that for a second. Would the mass be greater or less than the magnesium that was by itself? All right, and drum roll, we are going to put the crucible with the lid and the magnesium oxide back into the analytical balance. We are going to get our creative draft guard up here, and lo and behold, the two masses agree. We have a final mass of 28.329 grams. 28.329 grams. So now, with all of the data from throughout the lab, you should be able to tackle the analysis questions and the conclusion. And if you need any further clarification, reach out to Mr. Wheeler or myself. See you next time.